Okay, so what we're going to look at here is something called plotting time series. All right. So data in tabular form need to be plotted on a time series plot. This is similar to a scatter plot with some notable differences. Okay. So time series, scatter plot. The key difference really is that exponential variable is always time. I mentioned that in the previous video, which could be in days or weeks, time of the day, days of the weeks, months, quarters, so on, etc., etc., etc. All right, this is where that variable is time. Problem is sometimes, yes, I know I'm reading from this, but it's important is sometimes the labels are not numerical. All right, but for us to do a plot, which, time series is essentially a scatter plot in a sense, but it's just very specific that it's the x's, like I said, always time. This needs to have numbers, that plot there. I can't put week 1, week 2, week 3, week 4, or like week 1 to 4 for a month and then week 1 to 4 for a month. It doesn't work like that. Okay, so we need to make what we're going to call a time code in a moment. I'll show you. So to do this, the points are connected, so we can work out, is it seasonal? Is it secular? Is there a structural change? Is it cyclic, etc.? In that sort of stuff. So what we need to do is make what we call an association table, and this provides a time code that we can reference when we're making our predictions. All right. So what for example here, week 1, Monday, week 2, so it's week 1, it's going Monday to Sunday for week 1. Week 2, and you'd go on to finish week 2, but you can see the time code saying that's 1, 2, 3, 4, 5, 6, 7, 8. But the key point being here, by putting this time code in, we can actually graph that and get something worthwhile from it. If we try to graph that, it ain't going to work. The same could be said for the months of a year, as an example given here for January 2009, because that could be what's in graph. So you give it a time code. All right. The week beginning, again, you need to, I'm not going to plot this here, but you need to convert that to a time code. So as I've shown here, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the key in all this is knowing what that code is. So if I said, say, for this thing here, I said, what is going to be, if I want to predict what it's going to look like in, I've done a linear, what's it called, a linear regression, but I want to know what it's going to be like in October 2009. So October 2009 essentially is this one here, all right? So I need to be able to think, well, October that, if that's 8, this would be time code 10. So I'm going to put time code 10 into my line of best fit, my regression line equation, sorry. All right, but it's knowing what that time code clearly means in terms of what you're seeing. So same for this. I could say, what's the time, I want to know what's going to be on the 19th of March, that's time code 11. The week beginning the 26th of March, that's time code 12. Again, that's 11, 12, and that would be 26th of March. Okay, that's how you use these things here. All right, can you plot this as is? No, you have to do these time codes. All right, so the key point here, construct a time plot for the data presented below. So the years are being shown here, and the time code's being given. Sometimes you can get away, if it's giving you as a year as 2001, 2, 3, 4, 5, 6, you can get away with that. And I'll talk more about that in class, because there was an exam question from 2017, which from memory, I have to check it up again, but it depending on how you did it, you would get a different answer based on this, okay? And but what you put in your calculator, in terms of what we've been talking about in terms of a time code, is you put the time code in here. All right. And that's what we're talking about here in terms of what we're looking for. All right, here's how you put all your information in, you've plotted it up, and if you want to join the dots, you put it in like this. Okay, if you want to display as a connected time series. And as I've said here, you can do your regression, which you know how to do, but you need to remove any of the outliers. In a trend line, well, we only have to worry about trend line can be fitted when the pattern is time series is linear or can be linearized. So remember, you could have transformations here, but we're using least squares regression. Okay. And remember to remove any excluding outliers. So I'm going to finish that there. This is a shorter one than the previous video. Okay, next set of videos we'll be looking at smoothing time series and moving means and stuff like that, which if you haven't seen that before, you'd be probably going, what the hell's that? But we'll get to that in another video. Okay, thank you.